Hey there, all you cool people out there. We're doing chapter 15 test. I just did the Zoom and I forgot to record it. Actually, it's okay though, because when I recorded it, it gets really choppy. So this is the chapter 15 test, and I'm just going to give everybody the opportunity to see exactly what I went through in the Zoom. I'm just going to give some pointers for the test. This says write the percent as a decimal, 66.7%. And we discussed the idea of D2P. This is decimal to percent. If you start at a decimal, that means you don't have a percent symbol on the number. You move the decimal 2 places to the right. That's the same as multiplying by 100. And that converts whatever you start with to a percent. If you start with a percent, that means it has the percent sign symbol. You move the decimal 2 places to the left. That's dividing by 100. And that converts a percent into a decimal. So that was the hint that I have on the first question. Now I'm going to go to number 2. How would you write an equation to describe the following? 35% of what number is 21? And we just talked about the meaning of words. Don't forget that any percent in an equation that has decimal numbers that aren't percents, you have to convert those percents into decimals. The word of, as we've discussed many times, means multiplication. Anytime you see what number or what amount, what number, of course, is going to be a variable. And is, the word is always is an equal sign. And all the forms of is, was, there are, those are all different words that mean equals. That means you have an equation. All right, that's number 2. Let's go on to number 3. I apologize, my computer's so slow. And this one, really, it's just the same as the last one. Is means equals. What percent or what amount is going to be a variable? Of means multiplication. And then you solve an equation using the properties of equality, addition, subtraction, multiplication, and division properties of equality. Percent change. Percent change is always written as a ratio of the difference between the original amount and the new amount as a ratio over the original amount. And the original amount in this question is what you start with. So 15 bookabonks, that's the original amount. The difference is always positive. So I'm going to put a little plus sign. Difference is always positive. It could be negative if you're doing a decrease, or positive if you're doing an increase. But since we're using the word decrease or increase after the number, then we don't worry about the sign in front of the number. The increase or the decrease tells us which direction we went from the start value to the end value. Okay, moving on to the next question. This says, find the final amount, $84 increased by 12%. And in my class, there's a lot of ways to do this, but in my class, we always focus on the percents first. So we start in percent land, and the original amount is always 100%. So the original amount is 100%, and in this case is $84, right? And what we want to move to is the new amount. And what do we know about the percent of the new amount? We know that it's 100%, which is the original amount, and it's increased by 12, so we're going to add 12%. So you get some new percentage, and that new percentage, the new percent, is going to be multiplied by the original amount, and that should yield the new amount. Okay? Or final amount, I guess. New, final. A lot of times in math, the reason it's hard is because you have different words that mean the same thing. So you can't just memorize one word. You have to think about what those words mean. Okay, if a piece of lettuce at Mr. Ripoff's is typically $340, but today is 10% off, what's the sale price? Sale price is the same as the new price or ending price or final amount. So what we're going to do here is we're going to start with the percentages, just like we did before. I don't know why I wrote percent really big in the last one. But the original amount is always 100%, right? Okay, and in this case, that's $340. Whoa. And then today it's 10% off. So the sale price, instead of being 100%, it's 100% minus the 10% because it's 10% off. And then whatever that new percentage is, or the sale percentage, I guess I should call it, sale percentage. Let's see if I can save that. Sale percent is going to multiply the original price, and that's going to end up with the sale price. Okay, all right, just moving, trucking right along. I can't believe how good we're doing. It's amazing. It's amazing. So next one, at Buka's Bargain Barrel, you can buy a barrel to store your old socks. Today there's a sale for 38% off. Woo! With a sale price of $6.20. So this is kind of interesting because the original price is unknown. We do know that the original percentage was 100%, but we don't know the actual original price. We don't know the original price. It's unknown. I'll put a little question mark. But for the sale, we know a couple things. We know first that the sale price is $6.20. We also can figure out what the percentage must have been after the sale was applied. So if the original cost or price was 100%, it's 38% off. So you take 100% and you subtract 38% and you get some difference, right? And that sale percentage is going to multiply the original price, which we don't know. It's going to multiply the original price, and it's going to equal that sale price, which is $6.20. So you have to find the variable, what that sale percentage is, times that original price equals $6.20. You have to solve for this variable. And so you're going to have to use one of the properties of equality in order to do that. I'm not going to tell you which one, but it's the inverse of multiplication. You're welcome. Okay, last question is find the balance of the account, which earns simple interest. Before we even look at the numbers, these two words have formulas that go with them, right? So I'm going to start with the simple interest formula. That's I is equal to PRT. And then balance is going to be balance is equal to the principal plus the amount of interest. Okay, so what you're going to have to do is you're going to have to first find what I is, because you have $2,000. That's how much is being invested, the principal, 9%. But if 9% is going to be substituted in for the rate, it must be converted to a decimal. 6 months. Remember that time in simple interest is always in years. So 6 months has to be converted to years. And to help you with that, remember that 1 year, this is your conversion factor, is I don't know why I did an arrow. 1 year is equal to 12 months. Okay, so hopefully you'll figure out what 6 months is in terms of years. And then once you have that interest, you can substitute it into here, whatever that value is, add it to the principal, which you're already given, and then you should get your balance. And the final answer here is going to be the balance is equal to some number, and that number is one of these. All right, everybody, that's it. You've all been amazing. Thank you for everybody who came. Sorry about the people who could not, but hopefully this will help you out. I'll see you the next time.